Hey everyone, I hope you are all doing great. Today we are diving into a really exciting and practical topic, an architecture framework to handle triggers in Salesforce. In my previous video, I showed how to use a virtual class for trigger frameworks, but this time we are taking it up a notch. This is a more robust, architecture focused approach that gives you better control and structure as your org grows. Now, let's be honest. If you have worked with Apex for a while, you have probably written more than one trigger. But writing a trigger is just the beginning. As your org grows, so does the complexity. That's exactly where an architecture-based trigger framework becomes essential. So what does this framework help you with? Order of execution, separation of concern, recursion handling or reentrant code control, and most importantly, clean structure and better organization. I will break down each of this point in this video. First up, what do we mean by order of execution? If you have written multiple triggers on the same object, it becomes hard to track which one run first. That's why in this framework we'll follow a best practice, only one trigger per object. This architecture uses dispatchers and handler to manage different scenario. Don't worry, we'll come into details about what is dispatcher, how it works, how handler works, everything will be explained in detail later on. So buckle up your seat and just watch the video. So now coming back to the topic, so you never need more than one trigger per object. Next, separation of concern. In other frameworks, you might just redirect trigger events using helper classes. But here, we use object-specific dispatchers that route each event to its proper handler class. This keeps your logic clean and modular. This framework also handles recursion and reentrant codes safely, so you don't end up firing the same logic again and again, repeatedly. And all of this benefit led to better structure and organization in your Apex code base. I will now walk you through the UML diagram, explain how everything fits together, and show how it's mapped to the actual code. The full code is also available on GitHub. Check the description for the link of the GitHub. Now, let's come back to this UML diagram. Okay, so this is just the screenshot of the same UML diagram that I'm showing you in the slide. So it starts with this particular in here it start. So this is the start section, I mean entry point where it start. So when a trigger's executed, whenever we update a record or inserted a record or delete a record in Salesforce based upon in which you have written, in which trigger event you have written your trigger, based on that your trigger will be fired. Now, once we inserted or updated any record or deleted any record in Salesforce, it will see whether any trigger exists or not. If it does not exist, well and good, process end, nothing else. If it does not, if the trigger exists, if we get yes, then implement this trigger framework. So at first, we will create trigger for each object. And inside that trigger, there will be only one line present. I repeat it again. only one line present, no other line. All the logic, all the business logic, all the dispatcher class, handler class, everything will reside in some other classes. But in the main trigger, only one particular line will be present. That is trigger factory dot create trigger dispatcher, and you will pass as object type. Let me go to the code so that you can relate it well. So I have already logged in into my Salesforce org, and this is my developer console. So I have created one trigger for device type. So device type is a custom object that I have just created, and in this particular object I created it for insert, update, delete, like for all the event that is present in the trigger. I have I have noted down here. And then inside that trigger, I written only one line code, that is trigger factory dot create trigger dispatcher. This will handle everything. So now what is trigger factory? So this all the developer, whenever they create a trigger for a particular object, whether it is a custom object, standard object, they need to write this code. So this is like for each object, wherever you require a trigger, you need to write this code. Now, trigger factory. Trigger factory, this will be provided by, so this is my trigger factory. Okay. And if I go little bit down, so here you can see provided by framework, and that is using this pink color. You can say it pink, or yeah, pink. This will, I call this as orange, and this will be green. So using this pink color, whichever box is updated as pink, as marked as pink, those will be provided by framework. That means you create it only one time, and then all your developer, all your like whosoever will write a trigger, they will use this framework. Whatever class is provided by the framework, they can use it. They no need to write it again and again. So that's why we have marked it with the pink color, and that is provided by framework. The one that is like required, that is like definitely need to be written by developer, that we marked as orange, and whichever is optional we marked it as an green. So now coming back to this one, that is trigger framework. So in the trigger framework, what we are doing, we are actually invoking the trigger dispatcher, and trigger dispatcher will invoke trigger dispatcher base and iTrigger. So what all of these classes will do, that I will tell you, that I will explain you. So you can able to see four classes involved in the trigger factory. So you might be wondering why this much of complexity we need to use. Like we can write our code inside the trigger framework, inside the trigger, and we don't need this all these things. So there comes, I have already told you what is the benefit of using a trigger framework. Now trigger factory will create the dispatcher. What does this mean? So create trigger dispatcher means there is some role of your dispatcher class, like to which it will route your trigger event, and where it will handle those trigger event, and like run your business logic, that will be handled by dispatcher class. So create trigger dispatcher will help you to automatically at runtime generate the trigger dispatcher class. And if means you no need to hard code it, you no need to change it every time whenever you create a trigger dispatcher. You just maintain one naming convention, and using that it will automatically fetch that dispatcher class if it exists in your org, and done. So let's see how it is working. So in the trigger dispatch, in the create trigger dispatcher class, first it will do what is get trigger dispatcher. It's pass the S object type. So in the S object type, here we are passing the device type as the S object type. So as this trigger factory is the part of the framework, so we need to make it like generic. We can't typecast it with device type object because it will be used by all of the classes. So that's why we pass S object type. And once we pass the S object type using create dispatcher and get trigger dispatcher class, what we are doing, whether it is a custom object, that is it ends with underscore underscore C or not. If it ends with underscore underscore C, then we are fetching the dispatcher class as just we are removing underscore underscore C. And so for device type, device underscore type underscore underscore C, in this case, what it will do, it will only take device underscore type and it will append trigger dispatcher, and boom, is this will get this class. This will able to find this class if it is exist in your org, that there is one class exist called device type trigger dispatcher, and I need to route the trigger request into that class. After that, my job is completed. So once it find that particular, so suppose for account or contact, in that case, it is not appended with underscore underscore C because those are standard objects. In that case, it will be account trigger dispatcher. And you need to, while create that trigger dispatcher, because device type trigger dispatcher needs to be created by developer. See, that is in orange. So provided by developer, that is required. So trigger dispatcher is required, and that needs to be created by each and every developer whenever they are creating a, a, a trigger. So they need to follow that naming convention, that is account trigger dispatcher or device underscore type trigger dispatcher. Like that way it will able to find that dispatcher. If it is not able to find the dispatcher, it will throw an exception. You can very well use like a custom exception type and you can throw that one. For the timing, I have just used this one. Now, once it is done, once we find the trigger dispatcher, then what we'll do, we'll call that execute method. What this execute method will do, so it will check whether it is before insert, like before insert, before update, before delete, or after insert, after update, after delete. Based upon that, it will call dispatcher class that particular method. Now, you might be wondering what is trigger parameters. So let me show you what is trigger parameter. Trigger parameter is here we have used different type of before insert, because every time we don't want to use like trigger dot before insert, trigger dot before update. We don't want to use, or trigger dot old map, trigger dot new map. We don't want to use like that. So we just created an enum for that one, and also all the old list, new list, everything we created, and just based upon like whether it is before and is insert or not, we are using before insert like that. So yeah, we are assigning the value like that. That is trigger event dot before insert. Okay. So now coming back to this one, so I have explained this one. So we using the trigger factory, we create this trigger dispatcher, and trigger dispatcher able to find this particular class that we create per object, right? So this much is clear. And how are we creating create dispatcher? Using get trigger dispatcher, this particular method. So once we get that one, then we'll execute, call the execute method. Execute method will execute. So if I go here, execute method will execute the particular event, trigger event in that particular dispatcher class that we have found using get trigger dispatcher method. Okay, so this one is explained. This one is also explained. Now coming to trigger dispatcher. Trigger dispatcher I created as device type trigger dispatcher. Now trigger device type trigger dispatcher, if you see it, it is extending one virtual class, that is trigger dispatcher base. That is nothing but this one. And trigger dispatcher base is a virtual class and is provided by the framework. That means you need to implement it just one and you can use it anytime. So let's see first what is there in the trigger dispatcher. Before going to trigger dispatcher, let me show you what is iTrigger dispatcher. iTrigger dispatcher is nothing but an interface, and we just used different method that we are going to use per event. That is whether it is before insert. We want to execute our code in a before insert, whether we want to use our code in the before update. Based upon that, we created different method. And also we created bulk before and bulk after. Suppose before insert or before update or before delete, everything has some shared or common code. In that case, you no need to write the same thing again and again in before insert, before update, before delete method. Rather, you use bulk before method and you can write your code in that one. Same goes with bulk after. And after each of this like execution, if you want to do something, some common code after the execution of all this method, then you can use and finally. Okay, so this is an interface. Why we are using interface? We are using interface so that our all the trigger dispatcher class should follow the same pattern. It should not be like that, that one dispatcher is using some else something like before is before insert, is before update, something like that method, and some other trigger dispatcher class is using some other method name. We don't want that inconsistency. We want a consistency in our trigger framework. So we use interface. Now you might be wondering, okay, that is fair enough. For consistency, we are using interface. So why don't we use the interface directly on this particular device type trigger dispatcher? Why we created one more layer of virtual class? Okay, fair question and very valid question. So why we created a dispatcher class? Because suppose you are writing your trigger only for before insert and that's all. You want to write your business logic only for before insert, not for any other method. But if you use an interface, if you implement an interface, you need to you need a method in your class. So every class definition you need to write it in your dispatcher class. We don't want it. So that is why implemented a new layer of virtual class, abstract class, and there we have written all the method and whichever you needed that you can use in your trigger dispatcher handler that is created by your developer. But here all the method will be defined. All the method will be the method body will be written in this dispatcher trigger base dispatcher. Sorry, trigger dispatcher base in this one. Okay, so that's why we use this trigger dispatcher base. And also in this particular class, we handle the execute thing and get trigger handler class. Both of this we written in this trigger dispatcher class, so that in this abstract class, so that you no need to write it again and again. You just call this class, call this method, and it will do their job. So in the execute method, it will check what is your handler class, and based upon the trigger event, it will redirect to that particular handler class. And also how to get the handler class, the same thing I have used the same pattern, that you use the same naming convention, that if it is underscore underscore C, then you append the trigger event, and then after that trigger handler. In this particular case, what we are doing, we are not using the event, we are only appending trigger dispatcher, but in this case it is required to use trigger event, because for each and every trigger event we are going to create a new class that I will show you later in the diagram. But for the time being, get trigger handler, we are getting a trigger handler and we are executing those trigger handler using this trigger dispatcher class. So this is the trigger dispatcher class, and this is the interface that I have already explained. Now coming back to our object trigger dispatcher thing. So this is done, this is done, this is also done, this is also done. Now trigger dispatcher. So yeah, now coming here, so we then, based upon our requirement, our business logic, we will override whether we want it for before insert, before update, and all those things. We just override those particular method. No need to like no need to write all the method that is present in the interface. So that is the beauty of abstract or virtual class. Okay, now in the before insert, first we are checking whether our before insert is in progress or not. If it is not in progress, then we are getting our handler class using this. Now this is my I'm extending this class so I can directly access all the method of this class. So this is my get trigger handler. I am directly accessing the get trigger handler, and I'm passing as object what is the event parameter, whether it is before insert, before update, or after update. What is the trigger parameter, trigger event? I'm passing that one, and it is providing me the handler class if that exists in my system. So if it exists in my system, well and good, otherwise throw an exception. And then once I know that it started like in the before insert, I will make it as true, and then after execution happen, this execution completed, I make it as false. Why this is required? This is required because of recursion, so that we can handle recursion efficiently. We can handle re-entrant code efficiently. That's why this 3 line is very important. I repeat, very important. So, and if suppose you are doing something in the before insert, and again you are calling before insert some then in that case what will happen, it will set it as true, right? We are setting it as true, so it will not enter in this class, rather it will go to the else and execute this one. Okay, so this is the handler class. I will come to that later. So this is how here you can override before insert, before update, and after update, and you can connect the handler class in this one using this get trigger handler. So this is where it came here. From this trigger dispatcher, it is coming to the handler base. This is the handler base. This is the I trigger handler and high trigger handler base. So from here it is coming to the trigger handler base. So you can see, right, this much of code, this much of code is actually trigger dispatcher code. So it is only used to find the dispatcher class and handler class. What is your event? If your event is before insert, then which handler class to call. That is all, like the dispatcher thing is all handled by this four classes. Okay. Now this is all about trigger dispatcher. Now let's come to trigger handler. Till now, we have not written any business logic. It's just how to find different class and like redirecting the work to different classes. That is what till now we have done. Okay, now coming to iTrigger handler. So now you can see we have used here handler classes. So iTrigger handler. iTrigger handler. So I have explained this to iTrigger handler. iTrigger handler is nothing but again an interface, and that interface contains only two methods, that is main entry and in progress entry. Same thing, why we are using interface to make all the method name consistent and the behavior of the trigger framework consistent. So that's why we are using interface. And after we are using interface for the same reason, this is the interface that I have just shown you. And then using this interface for the same reason, we'll add one more layer of abstract or virtual class. So this is my trigger handler base. This is my abstract or virtual class. And in this particular trigger base handler, I will, yeah, in the trigger base handler, I will implement this iTrigger handler. I implemented that and I have used both the method in this particular class. Once that is done, then let's come to this particular classes. This is nothing but handler classes, and those are the main classes where our business logic reside, where we write our main business logic. Now you might be wondering, oh my God, there is so much thing. But remember one thing, this much of class you no need to write. One, two, three, four, five, five classes you no need to write every time. It's just one time job. And one time job you are done. Use whenever a developer started to write a new trigger, they just need to use this object dispatcher and this five classes job is done. And then they can write whether they need to write a before insert handler or before update in handler based on their requirement. They can use any one of them. It is not those are not mandatory class. Only at least one is required. So those are not mandatory class. So that's why. Now let me go to an handler classes. So from here, I got the handler class name. Sorry, not this one, this one. So you can you can hard code the dispatcher name, I mean trigger handler name in your particular S object dispatcher class, or you can use the one that I have used, that is like get trigger handler. It's up to you. So now let me go to the device type before insert trigger handler in this one. So you can see, right, device type is the object name of the custom object name, and before insert is the trigger event, and trigger handler we are appending it. So maintain this particular naming convention, then it will be very easy. Then once you are here, then you just need to override, you need to extend the trigger handler base, that is this one, trigger handler base, and using this one, so you need to just extend it like way I have shown you, and you need to write your logic in this one. So here I have I have not written any logic here, a simple logic in this particular method. Why so? To show you or to demonstrate you how our recursion work in this case. Okay, now that is how this particular before handler or like after update, all these things I have implemented. But you can able to see I have not implemented all this one, right? Because I only need to write my logic in this one and this one. So why do I write all of this one? So that's why I didn't written anything. So yeah, that is all about like how this UML diagram connects with my code base in the backend, and how you can implement your trigger framework, this trigger framework in backend. Now let me show you a simple example when we insert that one, whether this particular class getting called or not. Because I need to see, right, whether this is working or not. Same for this one, when I update something, whether my this class is getting called or not, and whether my recursion is handled or not. Okay, let's see that one. Okay, let me go to the device type and let me create a new one. Before that, let me refresh the debug log and let me delete all of the existing debug log if there is any. Okay, there is no one, no debug log. Okay, delivery type, test, trigger, framework. Okay, let me save it. Let's see what happened. Okay, it got created. Now let me show you the debug log. Okay, okay. Okay, so first what I want to see whether my this one has got the exact, I mean the correct handler class or not, or so let me see that one. Okay, device type, no, not this one, sorry. This should be trigger factory, because yeah, this one is correct, dispatcher, but before handler class we need to get the dispatcher class, right? Otherwise how will able to understand that whether this dispatcher is working correct or not. So let's see whether the dispatcher name is coming correctly or not. So this is the dispatcher. So trigger dispatcher class, device type trigger dispatcher. Okay, whether my name matches, device underscore type trigger dispatcher. Great. So it does matches. And so that is great, right? It does matches. So this one is very much important. Type.for name. This will actually help you to create that particular device type trigger dispatcher class. So this is a very important one. Okay. Now I got my trigger dispatcher. Now what? Now this is before insert. So it should get into the before insert. So now let's check. Inside the before insert, did we get handler class name in line number 16? Let's check that one. Yes, at line number 16 it got that class name. And what is the class name? Device underscore type before insert trigger handler. Does it match? Let's see. Oh, bingo, it does match. Device type before insert trigger handler. Now let's see whether it called the main entry method or not. So let me find it. Yes, it does. So it does inside main entry write your business logic, and this is the new list that I'm printing. So this is the new list that I'm printing. So my trigger is working. My trigger framework is working. So see how easy it is? Like it's very easy. You can like just follow this trigger framework and then you will able to handle trigger in much better way. Trust me, in much better way. Then let's update this one. Then let's see whether my this particular trigger handler got executed or not. Okay. And here what I am doing. So I'm printing this too, same as the first one. And then I am getting the new list. And as it is after update, so I want to update the name. But before that, what I need to do, I need to query it. Because if you don't query, you will get an read-only exception. So once I get the query, and then what I will do, I will update the trigger name only for one device type. I just wanted to update the name. And then once I update the name, it should not come back to this particular main entry because my main entry is still not complete. It is updating, right? So if it is updating, then it should not again come into this main entry and trying to update the again and again. So recursion will happen. So rather when this particular main entry is executing, it should go into the in progress one. That is how my recursion will be handled. So that is what we written here. Where is that? Yes. So if it is executing, let me go to the after update. If it is executing, then don't come to this particular class. Don't come to this particular if condition. Go to this execute. And in the execute, just call. So if I go to the trigger dispatcher base, you can, no, not this one. If I go to execute, right? And it is trigger dispatcher base, yeah. In this execute one, sorry, this one. So if handle class is not null, then it is like it will call your before insert handler main entry. This is the handler class, handler dot main entry. That is nothing but this particular method. But if it is null, that is what we are sending. If it is already executing, then pass the null. So if it is null, in that case, call in progress entry. So this is where my in progress entry will be called and my recursion will be handled. Let's see that one. So let me update something like this thing and trigger framework one, something like that, and save it. So see, my name updated with what? Updated from after trigger. So updated from after trigger. So my um, trigger framework is actually working and I did not get any recursion exception. So now let's see that one. So let me go back to debug logs and open the latest one. So this is the latest one. Let me open it. So let's check from the first. Okay, from the trigger factory, whether my dispatcher class name came correctly or not. Yes, it does. Device type trigger dispatcher. Then I will go to this one, whether my handler class name come correctly or not. Let's check that one. Yes, device type after update. It does. So the previous one is before insert, but this one is after update. So it does came correctly. And then let's check this. Okay. So this one inside main entry, whether it come inside this one or not, it does. And then new list is also coming. And then you might be wondering why we are getting three, because I have before update trigger handler as well. So I'm getting that one as well. And then let's see whether it is getting inside in progress or not at line number 19. Yes, at line number 19, it does get inside this one, in progress entry, recursion handle effectively. So yeah, that is how you can handle recursion effectively. So yeah, that is all about trigger framework. That is all about today's session. That is all about trigger architecture framework. Hope you like this video. If you like this video, Please do like, share and subscribe. See you soon in my next video. Thank you for watching this video.